This is going to be the third type of conic, and this is ellipses. So here is the geometric definition of an ellipse. So an ellipse is just basically all points in a plane where the sum of two distances, of the distances from two fixed points, and these fixed points are what we're going to call the foci, is constant. Now, you don't need to know much about the foci. The foci is just plural for focus. So basically what you have an ellipse. And an ellipse is just basically like an oval, kind of like an elongated oval circle. So you have 2 points here. Let me call that F1 and F2. And then let's say I choose a point, and this point is XY. This can be on the X and Y axis, I don't know. So basically what it's saying is that the sum of these distances is constant. So any point that I choose here will have the same distance. So D1 and D2, those are all, when I add those two, they're going to be the same exact distance. So if I were to look at an ellipse, ellipses can have two general forms. They can either be looking like this horizontally, or they can be looking like this vertically. So trying my best to draw them nicely. Now, the elongated side is what we're going to call the major axis. Okay, so this is also the major axis. And on the major axis, you're going to have 2 points, and these points are what we're going to call the vertices. So you have these vertices, major axis here, and then you have the vertices here. So this and this are what we're going to call the vertices. And just like with the circle, you are going to have a center, and the center is going to be right in the middle. So that's what we're going to call the center of the ellipse, center. Okay. Now, an ellipse has this form. I'm not going to derive the formula for you, but this is what it is because you just have to know how to use it. X minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. So if you notice, it looks very similar to the equation of a circle. The only thing that you have is that you now have something underneath it, and then this is equal to 1. So this a corresponds with the distance in the x direction. So here's the x direction, so this is going to be a. Okay, notice that it's a squared, so we have to be very careful when we have to square root this, kind of like how we did with the, no, we haven't done it yet. So kind of like how we did with the radius, so same thing here, and then b corresponds with the y direction, so this part is going to be b. Okay, so that's basically all it is. We'll do a couple of problems using this formula. And yeah, so let's start off with just some examples, and then maybe just graphing them, just so that you can get used to graphing these types of ellipses. So let's do an example, and I just want to graph. So let's start off with x squared over 4 plus y squared over 25 is equal to 1. So this is going to be an ellipse. Now, let me go back. I think I forgot to say a couple things about it. The center here, just like how we had it before, is going to be HK. That's basically what it is. So this H and this K is going to be the center. The A and the B, you'll realize what it is right now. So let's just try to graph this. The first thing that you want to kind of think about is what exactly is going to be the center of this ellipse. Now, notice that there's no h and k, there's no numbers next to it, so it must be 0, 0. So it must be at the origin. Now, the way that I usually think about this is that first I look at the number right below the x value, which in this case is 4. So in the x direction, the way that I know, because I know this is going to be the center at 0, 0, well, in order for you to know how far I need to go, well, all I gotta do is just take the square root of this number. So the square root of 4 is gonna be 2. Now I'm gonna go 2 in the x direction. So I'm gonna go 2 units this way and 2 units this way. Okay, so I have this one and I have this one. Okay, now in the y direction, so here's y. I'm going to take the same number, 25, right below it, and I'm going to take the square root of it, and that's going to be 5. I'm going to go 5 units up, 1, 2, 3, 4, 5, and then 5 units down, 1, 2, 3, 4, 5. And all I got to do is just connect them. And this is going to be the equation of my ellipse. Here are the vertices, as you can tell. My vertices is going to be wherever it's longer. And in this case, it's going to be 0, 5, and 0, negative 5. You don't need to write this if you don't want to, but it's really nice to know where the vertices are. So this one's an elongated vertical ellipse. So basically, whether it's vertical or horizontal, it will depend on what number is below the x or the y. So let's do another problem. So let's say we had x squared over let's do 9 plus y plus 1 squared divided by let's say we want to do 49 equals 1. So what is this one going to look like? Well, let's start off by drawing our coordinate axes, x and y. So first, let's figure out what the center is. So the center is going to be, well, notice there's nothing next to the x, so that must be a 0. In the y direction, it's going to be plus 1. Remember, this is always opposite. It's going to be minus 1. So the center is going to be at 0, minus 1. That's the center. Okay. Now, in the x direction, so starting here from the center, in the x direction, I'm going to go 3 units because it's the square root of 9. So from here, I'm going to go 3 units this way, 1, 2, 3. So from the center, and 3 units the other direction. So right there. Okay. And now, well, no. And now, what we're going to do in the y direction is going to be 7. So it's going to go 7 up, 1, 2, 3, 4, 5, 6. 7, okay, and then 1, 2, 3, 4, 5, 6, okay, because it's including the 0, and then 7 down, 1, 2, 3, 4, 5, 6, 7, so that's going to be negative 8. Okay, and now all I gotta do is just, oh my god, okay, so this is not the best drawing, but you get the idea. Okay, let's do a couple more. Let's say we had 16x squared plus 25y squared is equal to 400. So a couple things to look at. It's really, notice that this thing, it doesn't look very similar to the equation of our ellipse. What we need is this one to be a 1. So one of the things that we got to do in order to make this a 1, well, how can I make this a 1? Well, one thing that I can do is I can just divide the 400 over. Okay, so now that's going to make it into a 1. Now, what about this 16 over 400? Well, I can easily make that into, so 16 over 400, that's going to be 25, so it's going to be x squared over 25. And then I'm going to do 25 over 400. Well, that's just going to give me 16. Y squared over 16. Okay, so basically I just reduced everything out. So what is this going to look like? Well, the center is going to be at 0, 0, because there's no HK. So it's going to be 0, 0. And the x direction is going to be 5 units. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And in the y direction is going to be 4 units. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and all we got to do is just connect these things. Okay, and that's going to be my equation of the ellipse. So if you don't have something that's in standard form, in other words, making this into a 1, make it into a 1 by dividing it over. Okay. So let's do another one. So we're still graphing. 9x squared plus 16y squared equals 144. So notice that it's not in the correct mode that we want it. So we're going to divide this 144 over. Okay. So now we're going to have 9 over 144. That is just going to give me 1 over 16. So x squared over 16. And this is going to give me y squared over 9 equals 1. So center is still 0, 0 in this case. It's still 0, 0. And all I'm going to get in the x direction is going to be the square root of 16, which is 4. 1, 2, 3, 4. 1, 2, 3, 4. And then the y direction, 3. 1, 2, 3. 1, 2, 3. And then just fill in the gaps. Okay. So yeah, that's all there is to these types of ellipse. They're not too terrible, but now let's do something a little bit more involved. Something that I have to actually do a little bit more work. So let's say we have this example, and what we want is write the equation 6x squared plus 4y squared plus 12x minus 32y plus 34 equals 0 in standard form. Okay, so let's say we wanted to have this equation in standard form of the ellipse. So notice that in this case we don't have we don't have it in standard form. It looks just everything just got foiled out. So we're going to have to complete the square here again, just like how we did with the parabola. So let's start off first with our equation. So this is going to be 6x squared plus 4y squared plus 12x minus 32y plus 34 equals 0. Now I don't want that 34. I'm going to move it over. So I'm going to be left with 6x squared plus 4y squared plus 12x minus 32y equals negative 34. And now what I'm going to do, I'm going to group my x's with my y. So I'm going to group all of my x's first. So my x's are going to be green. So this is going to be 6x squared plus 12x. This is going to be my group of x's. And then I'm going to group my groups of y's, which is the 4y squared and the minus 32y. Plus 4y squared minus 32y equals negative 34. Okay, now before I complete the square, I want to go ahead and factor out a factor of 6 because I want it to be a 1. 6x squared plus 2x plus, now we're going to factor out a 4 here. It's going to be y squared minus 8y equals negative 34. Okay, and now what I want to do, now that I factored everything out, now I'm going to complete the square. So here's 2. I'm going to take 2 divided by 2 and then square it. That's just going to give me 1. So what I'm going to do, I'm going to add 1 here. Okay, now with the blue one, I'm going to take this negative 8 over 2 and then square it. You're going to get negative 4 squared, which gives me 16. So you're going to add 16 here. Okay, now we can't just do that. Okay, we added a 1 here. Notice that there's a 6 here. So what am I going to add on the other side? A 6, so a plus 6. Okay, now for this one, I added a 16 there. And I have a 4 outside. So 16 times 4, that's going to give me 64. So I'm going to add a 64 here. Okay, so that's what I got to do. So like make sure that you don't forget those. All right, so what am I going to get? I'm going to get 6x plus 1 whole quantity squared, then plus 4, y minus 4 whole quantity squared equals 36. All right, so now I'm going to divide by this 36 to each of them. So I'm going to get, so 6 into 36 is going to give me x plus 1 whole quantity squared divided by 6 plus y minus 4 squared. This is going to be divided by 9 equals 1. So here is my standard equation for this ellipse. Now I can also graph it, so just to practice a couple of my graphing. So my center here, it's not going to be 0, 0 anymore. It's going to be -1, 4. Okay, so here's -1, here's 4. 1, 2, 3, 4. So there's my center. In the x direction, I'm going to be going the square root of 6. Okay, so I'm going to go square root of 6 units this way and square root of 6 units that way. Now, if you think about it, you go to your calculator, square root of 6, that's going to be about 2.5 units over. So 2.5 units over, 2.5 units over. So this is 1, 2.5. Okay, so somewhere around there. So remember, this one's going to be square root of 6, which is about 2.4, 2.45. And this is going to be 3 units over because the square root of 9 is just equal to 3. So 1, 2, 3, and then 1, 2, 3, which is going to be right here. So all we got to do is just draw my ellipse, which kind of looks kind of weird, kind of dumb. Okay, so if I drew this correctly, okay. And that's what it's going to be. So sometimes the thing that you have to square root might not be a perfect square, which is fine. Just use the decimal, just approximate. And I know completing the square is kind of annoying sometimes, but notice that nothing really changes as long as you kind of get used to the completing the square.